Everyone, we will solve this today's LeetCode problem. This is LeetCode medium. Find the winner of the circular game. So the question is, there are n friends that are playing a game. The friends are sitting in a circle and a number from 1 to n in a clockwise direction, right? And more formally, moving clockwise from one friend brings to you I plus one nth friend for 1 to n, and moving clockwise from nth friend brings to you the first friend because it's a clockwise. So after moving from nth in clockwise direction, you will ultimately reach to the first friend, right? So the rules of the game is: start at the first friend, count the next k friends in the clockwise direction, including the friend you started at. The counting wraps around the circle and may count some friends more than once. Right? We will see this line. Right? This is means that if k is greater than n number of n friends, so some friends will be counted as multiple times. That's the meaning of this line. Right? So the last friend you counted leaves the circle and loses the game. This at the kth position, the kth position, the friend which is counted will be leaves that circle and loses the game, right? And if there is still more than one friend in the circle, go back to step 2 again. We will start from this point, same friend, and started counting k friend after that. And again the same thing will happen, that he will lose and repeat the same thing. Means we will the friend which we have counted till at the kth position will leave at the that game, and the last friend which will be left out in the that circle wins the game, right? So basically we need to find the given the number of friends and integer k, return the winner of the game, right? So basically the question is asking that, if you see in this example, the first example, n is equals to 5 and k is equals to 2. So basically this 1 2 3 4 5 uh, 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 friends are in circle, right? And we have k is equals to 2 given. So the question is, question it given that we need to also include the friend from which we have started at, right? So it means if k is equals to 2 given, we will count k minus 1. So they see we will start from 1. So count this as a one friend, then second, which is at, so at second position 2 is there. So this two elements should be removed from the circle, so it will remove from the circle. But when we move again from the clockwise, this two friend, the second friend, the second friend will be not counted. It will, because it has just removed, so we will start counted from the next element. So this is 3 as a 1 and 4 is 2 again. So 4 will be removed again. After this 4 is removed, we will start from this 5, and this 5 is counted as 1, and this 1 is counted as 2 again, because it's a clockwise direction. So we will, when we move clockwise from after 5, it will move to 1, right? So this 1 is again removed. Now when you again moved 2 points, so this after this 1, this 3 and 5 will uh, left. So 1 and 2, so this 5 will remove. At last we have only a friend left, which is 3, right? At last only a friend left, which is 3. So it means, what does it mean? It means that this 3 is a winner for this game. And if you see constant here, this k and n is 1 to 500, right? So it means I can do it in either o of n into k for course, or I can also do it in o of n squared for sure, right? I have determined by seeing the constant that I can do in this both, right? So basically at each step, if you see here, at each step, what is at each step what is happening here? At each step we are moving we are moving till k minus 1th friend, and removing them remove that friend from the circle, right? From the circle, and again uh, iterating the same way, again iterating the and again doing the same thing again and again, same thing which with rest of the friends, right? So one thing is clear, that we are moving in k minus 1th friends, and remove that friend from the circle, and again doing the same thing with the rest of the friends, right, in the whole clockwise direction, again and again, again and again, till we are moving again k minus 1 friend, then remove that friend. In this case, see, we move in k minus 1 friend, second is removed, again same for 4 is removed, again 1 is removed, again 5 is removed. So basically, the friends, after removing that friend left, we will do the operations on that, right? So basically, we need to just simulate this process. We just need to, we just need to do implement we just need to simulate the process which which the question is asking, right, which the question is asking. We just need to do that, right? We just need to do that, but how we will do that, right? So basically, what is happening, we need to return the friend number, which is 3, right? So after removing this 1 to 3, we ultimately want the friend numbers which will be left. So for that, I need to anyhow maintain this third number, right? Maintain this the final answer, because I need to return the friends number, right? So ultimately, I need to anyhow maintain this friends number, right? So for that, what we need to do, what we think of what we think of that, after removing any friend, after removing any friend, don't you think that I need to maintain the, because this is given in a list, right? This 1 to n is a list, right? 1 to n is a uh, 1 to n is a, like this, 1 2 3 4 5, right? So after removing any any friend, this must be updated, this must be updated, this order must be updated. Suppose I removed 3, suppose I removed 2. So this, now we have 1 3 4 5. Now we don't have 2. So if I generalize for the things, so that will be not good, that would not be correct, because now the list is updated. Again, when we remove 4, now again the list is updated. So I need to maintain this list, because at last the number which is left in this list, that would be my answer, right? But how we will maintain this, how will you maintain this, right? So basically, if you see, the after removing the list must be updated, right? The list must be updated, must be updated. So for that, what I think of, that I can use any data structure. Either you can use a vector, or I can use any other data structure. So if you use a vector, you need to iterate in whole this 1 2 3 4 5 1 to n, again and again, again and again. That will take O of n square. That will definitely take O of n square, right? If you update, suppose you move till k, and then removed this two elements, and you need to again update this after removing this two, 1 3 4 5. Again for 4, you remove this, then you again need to iterate in 1 3 5. So that will definitely gonna take O of n square. But can we do this in another way, right? If I use vector, if I use if I use vector, it will definitely gonna take O of n square, which is that I need to just simulate the process. I will just simulate the process, that I will move till k minus 1, and then remove that element, and update my vector, right? Update my vector, right? So I will update my vector. So after update, it will become 3 4 and 5. Now I will simulate the process in this. After this will again updated 1 3 5. Again this will be updated after this, right? So same thing happening again and again, again and again, right? And the last element which is left at this stage, this will be our answer. So that will gonna take O of n square, right? But can I use another thing, that I do not need to simulate the same thing again and again? So if you use q data structure, if I use q data structure, so what will happen? See, uh, one thing is clear, that in the vector I need to update the whole list. In vector I need to update the whole list to do the operations on this, right? I need to update the whole list. That's why it was taking O of n square. But if you observe here, if you observe here that 1 2 3 and 4 5, after this, if I take another thing, 1 2 3 4 5 and again, right? If I take another thing, So one thing you observe here, that after this, when k is equals to 2, when k was 2, this this needs to be only removed, right? This needs to be only removed. Other things are all the same, 1 3 4 5, all all are same, all are same. Only this 2 is removed, right? Only this 2 is removed. It means before this it's not changed, after this is it is not changed. What it changed? Just this 2. So if I do on if I anyhow if I can only uh, do like this, that I don't need to iterate in whole of n to update the list. I will just iterate till o of k. So can we do that? So see, if I use a queue data structure here, if I use a queue data structure, so what does queue do? Queue can queue is first in first out, right? Queue is first in first out. So the element which is this is first in first out. The element which is insert first, it will be first out, right? First out, right? So basically what we can do, when we I have started from one, so I have included all the elements, right? That's need to be sure, right? Because I will do the operations on this queue only, right? Basically it was before that list. Now I will use this queue data section only, this only one queue. Here we have I need to update the vector again and again. That's why it takes taken O of n square. But I will use this queue to update only some of the elements, not whole data structure, right? Then it's something beneficial for us, instead of using vector to this queue, right? So what we'll do, see, here k was given as 3, right? So let's take k as a 3, not 2, right? This is leave this example. Let's take k is equals to 3, right? Now let's take k is equals to 3. Now what we will do, we will check that whether q has. So now k is equals to 3 means till 2 elements, right? Because when we include this one, so 1 2 3, this 3 will remove, right? So what we will do, we will move till third friend. We will move 3 third friend, right? So this third friend needs not to be included. So what we will do, we will insert this 1 and 2 again. Because why we are inserting it? Because when we remove this elements, when we remove this when we don't want to include this third number, I need to pop this out anyhow from this queue. So simply think of like this, like 1 2 3, and I need to remove this third element, this 3 element. How will you do that in queue, from queue, right? How will you do that in from queue, right? And this 1 2 needs to be inserted at the same place without disturbing it. This needs 3 needs to remove. How will you do that? So what will do that, you will pop out. But if you pop, this 1 will remove again. If you again pop, this 2 will remove. If you again pop, then this 3 will remove, right? Because this is first in first out queue. So if you remove this third 2 and 1 again, and 1 2 positions should be the same. So after third pop, this 3 will remove, right? But this 1 and 2 is also removed, so you no need to be insert this again. So what will you do, you will again push this 1 2, again push back this 1 2 to my queue. So this will be like this, right? This will be like this. And this 1 2 will be removed. So this 1 2 and 3 always removed. So what happens, see, if you see this is clockwise direction. So after 5, 1 and 2 will be definitely be there. So this is this is the help of this clockwise direction, that after this 5 1 2 definitely come. And we have just removed our 1 to 3 elements, right? Till k minus 1th I have removed, and the last element which is 3, which we have removed also, right? So basically what happening is, we will remove again and again the same thing. So now the k is 3, right? Now k is 3. So we have removed till 1 2 or 3. Now the same thing happened. So now what, which element will be will get removed? Of course this 4 and this 5, because we ultimately want this 3 element. So with this 4 and 5, this 4 and 5 and 1, this 1 should not be taken now, right? Now this the updated queue will be 4 5 1. Now this 1, this is just is for visualization purpose, that I don't need to want 1, so I need to remove it. So for this removing it, I need to remove all the elements before it and insert in at last position. So 4 removed, 5 removed, and 1 removed, right? But this one should permanently removed from the queue because we don't want this one, and this 4 and 5 must be pushed back because we want this 4 and 5, right? So 4 5 1 ultimately removed, right? Again this 2 4 5, right? Again this 2 4 5. Now which elements we don't want? 5, this fifth element we don't want, right? Again 2 4 5 will all remove. 2 4 5 all remove. But which element would be pushed back? 2 4 5 will push back, right? 2 4 5, 2 4 will be pushed. We don't want 5 again, so this is removed. Now if you see here, k is equals to 3 and we have only two elements, right? K is equals to 3 and we have only two elements. So one thing is for sure, that the one thing is for sure, that the winner is only one. So we need to remove one elements, but which elements needs to remove? So see, one thing is clear, that we need only one elements, and one thing is clear that we need only one element, right? And k is equals to 3 here. So the third position after moving in back, the third position elements which will be left out, that will be definitely be my answer, right? So see, this 2 1, this 4 again second, and this 4 is second, and this second is third, right? 2 is at third, because 2 then 4 then 2. It means this 2 needs to be removed, right? Right, this two needs to be removed. So what we will do, we will just go from 2, so this will become 2, this become 4. Now this 2 should be popped out. So here the k is equals to 3, the second element, because we have started from the third element which needs to remove. So q is equals to 2 1, then 2, then 3. So what will happen now? This 2 4 2 will be present, right? So this 2 will be popped out and pushed back. So that will happen like this will happen like this, 2 4 2, right? Again this 4 needs to be popped out and pushed back. So this will be happen like this. Now when you again do that, we don't want the third element, right? Before, so what was happening, this k is equals to 1, this 2 will be popped out, but this needs to be pushed back also, because we don't want to delete this permanently. At second position, this 4 will be popped out and push back this 4. Now the third element which is again 2 must be permanently deleted. So this needs to be deleted, but this knots need to be added because it is at third position. Understood? Now we have only left with one element which will be our answer. So this 4 is our answer. Right? Understood that what we are doing for with Q. So what was happening here? What was happening here, that we have just we have just we are just iterating again and again. We are just pushing and popping we are just inserting and removing only the k minus 1th elements, only the k minus 1th elements, only the k elements, not k minus only the k elements, because we want to maintain the order, we want to maintain the order and the friends number, right? Previously what we are doing, we are updating the whole list due to this vector, but with the help of q, because it can simply remove and push back the same thing, because from the first part only. So we are just only needs to worry about this k elements, right? Because we don't want kth element, so we will push back only the k minus 1th elements and remove this k elements permanently, with maintaining the same order which we have just shown, right? So basically we just want to implement this the same process which we have done with q, right? So let's see how we will do that. So basically what we need to do, I need to take a q data structure, right? And I needs to put all the numbers of the friends present from 1 to n in my push, in my queue, right? Now what we need to do, we will remove and insert till what the process, till queue has a size greater than 1, right? Because if it has equal less than equals to 1, it needs to be deleted, because that's would be our answer definitely, because we definitely got our friend's answer, right? Now one thing is clear, that I need to go I need to iterate, right? I need to just iterate. So if I iterate from 1, if I iterate from I is equals to 1 till k, because I need to remove this kth element which is present. So what I will do, I will just iterate from I is equals to 1 to I is equals to less than k, which is k minus 1, and do the same process again and again. So what I will do, I will extract the front value, extract the front value, and push back this value with popping. Sorry, I will pop this out and push back the same thing, right? Why I'm doing this? Because we don't want we don't want the elements to be deleted permanently from 1 to k minus 1. We want only the kth element, kth friend to be deleted. So what we will do, we will push back the same value at the front part, because we have 1 2 3 4 5 elements here. We have 1 2 3 4 5 elements before 1 2 till and value. And when we do this, this 1 2 will again push back this right here, and this needs to be removed here, right? So this is maintaining order, the same thing, right? And we will just pop this, right? So what we have done, we have removed this one, we have pushed this one to at last, and we have removed this one from beginning, right? The same thing for 2, right? So that's what we are doing now. Now now see, the last element which we have left will be the kth element, so that needs to be deleted, so we will permanently delete it without pushback, right? Now the same thing goes again and again, again and again. Same thing goes again and again till q dot size is not less than q dot size is greater than 1, and at last we will just return our answer, which is q dot front value, right? If q dot size is equals to 1, so the front part, the one element which is left will be our answer, so the first element will be our answer. So this is how we will just simulate the process with q. You can if you use vector, that's the process will be the same, but this will happen till n. This will go from 1 to n values, right? So that's what happened. So we will run this. Let's see, we have corrected this. Sample case passed, let's submit it. Yeah, we have passed all the cases basically. So what would the time and the space complexity would be? So if you see here, we are moving till n, right? But we are updating only this 1 to k minus 1 element, right? And we needs to move in whole of o of n, right? So basically it is moving in o of n, but and also o of k every time, each and every time we needs to iterate to find the kth element. So that would be taken as o of time of complexity of o of n into k, right? And the space complexity, and the space complexity, so that would be o of n only, because ultimately the total number of elements which will left out in this queue will be o of n at any point of time. At any point of time, that will be o of n only, because we are removing and then we are pushing, and ultimately that would be o of n only, right? So space complexity would be o of n only, right? In previously using vector, that would be space will be the same, time would be o of n square, right? So where is this, where was the vector? Yeah, here, right? And what happened using q data structure, that would reduce to o of n to k. Now there is a follow-up question, that whether we can solve this in linear time with constant space, right? So if we think of something, that ultimately what is happening here, what is happening here, when this is given 1 2 3 4 and 5, and when any number want to leave removed it, so suppose this 3 is removed, so this 3, if this 3 is removed, this all indices of 4 5 got reduced to See, suppose before it was 0, 1, 2, 3, and 4. Now it was 0, 1, 2, and 3, right? So if I see this, that at k is equals to 2, for k is equals to 2, for k is equals to 2, for k is equals to 2, the second elements, for k is equals to, which is the this element, sorry, k is equals to 3, right? K is equals to 3, the third element which is present is just reduced its all the elements reduce its indices, and basically we just need to return this 4 value, which is 3 plus 1. So I need to definitely maintain the friends number and order, right? So basically, if you see, observe here again, when I again want to remove the third element, so which is started from fourth, so four, fifth, and one should be removed, right? One should be again removed. So this becomes two, four, and five. And if you see the indices, this is zero, one, and two again, right? So basically, what is happening here, if you observe something, that at every removing of friend, the indices is reduced, but how much? But how much? But how much is reducing? See, when this three removed, it is removed by, it is reduced by one element, because it is uh, reducible, right? It is reducible, so it is removed by one element. But if you see here, after this three, we started from four, five. It means if you see here, if you see this, this is started from four wise. So if you take this four as a starting element, so this will be something like this, one and two. So its index will be 0, 1, 2, and 3, right? If you see like this is not accurate, because after this 3, now the element which we have started is 4. So the list should be like this, 4, 5, 1, 2, because 3 is removed from here. So if you observe this 4, 5, 1, 2, 1, 2, and it started from 0, this is 0, this is 1, and this is 2. Now again, when you remove this 1, you have started from 2. So this will be 2, 4, 5. Now this 2 is reduced to 0, 1, and 2 index. So one thing you observe here, that the index is changing after each removable, and the index is changing till k. See how, what why I am telling k. See, when we remove this 3, this fourth number is at third index, so this 4 is now becomes 0, and all numbers are increased by 3 or decreased by 3, right? So that will be, see, 3 minus 3 is 0, 4 minus 3 is 1, 0, see, 1 is at becomes 2, because it is a clockwise direction, right? Now this 2 becomes at 3, 2, right? At 3 position, right? So basically what is happening, it is happening that it is just reducing the further elements and incrementing the previous elements by 3 somehow. See, again this 0, 1, 2, 3, when this 1 is removed, the second position is at becomes at 3, fourth position becomes at 1, and fifth position becomes at 2, right? The same thing is happening. It's the same thing is happening, right? So something is related to something is related to k, right? I can see that something is related to k. So basically we just need to find how is this functioning. So this 4 is this 4 is this 4 is reduced to 0. It means this index, suppose this fourth index, let's take the index of any element. Let's take the index of nth element as x, the current index, right? The current index. Let's take the current index of nth element as x, and now the x becomes y, right? After removing the element, after removing the element, after removing the kth element, its index becomes y, right? So what's the relation between this y and x? So basically its relation, if you see here, so definitely that would be depends on this 5, right? So when this, see, this 4 is reduced to 3 to 0, this 5 is reduced from 0 to 1, right? So when we see this 4 is reduced till 0, then 5 is reduced to 1, the same thing goes on, right? See, after this 5, 6, 7, the 5 is reduced to 2, 6 is reduced to 3, the same thing is happening again and again, right? So basically what is happening, that it is reduced by, all the indices are reduced by minus k, all the indices are reduced by minus k, right? Now when, it means for f and k, we will get the indices from f n minus 1k, right? If all the indices are reduced by minus k uh, for particular indices, for this 3, for this 3, when we remove this 3, so it means for this value, this needs indices will be removed, and it will give me a particular index, and according to this index, all the indexes are uh, adjustable, right? So when we remove this 3, this will gives me something like a minus 3, and this will, if this give me minus 3, this all are this all are be this all are will be, this all our indexes would be adjustable according to this previous indexes. It means it will, if it is give you minus 3, it will be same as 0, 1, and because these are all updated, updated. So basically if fn minus 1 plus k will gives me minus 3, all should be generated something like that, so that needs to be added. It means I will add k, because these all indices are reduced by minus k, so I will change it to plus k, because that's need to be how will I maintain this 0, 1 and 2. Understood? So how will I observe this? I have taken example, generalize this, and generalize this how, because this has just reduced to minus k. This is just a math, this is just a math tricks. If you know, you can solve this. If you don't know, you learn this, right? This is just like this, right? So this is because this is how something is representing. So we will use this, we will use this relation to solve this problem, right? So basically now it becomes as a recursion or a dp problem to find the friend's number, which is the our answer, right? So we will see that how we will use this uh, relation function to solve this problem, right? Basically, now if you see here that we need to we need to know the fn minus 1k. So this fn minus 1k also needs to know something from its previous values, right? The same thing goes again and again. So at last, at n is equals to when uh, so when this base case would be, so if you see here at n is equals to 0, because this would be definitely got till 0, right? So when n is equals to 0, it's but sorry, we have started from n, so this needs to be go to n is equals to 1, because we have only 1 to n elements. So when n is equals to 1, it will be definitely present at index 0, because this is representing indexes. This fnk is representing indices, representing index, right? Representing index. So and n is equals to 1, when we have left only with one element, it is definitely be 0. It will be definitely at it will definitely at index 0, right? If n is equals to 1, so that would be our, it is definitely at index 0. So this will be our base case, right? This will be the base case, right? So what we will do, we will just use a basic recursion function, right? So how will this happen? This will go like this: fn minus k, then it will moves to this is fn k, this will move to fn minus 1k. So again this will move to fn minus 2k, like this, right? Something like that. So it is a just a 1D array to solve this problem. So what will happen, this fn minus 2 will give me some answer, it will move to this, and we will add this plus k to here. So this will give me something, so this will add it, and this will be again plus k. Now one thing is happening, that I want the index number. I want the index number, and that would be definitely, that would be must as friends number, right? Friends number. So when you add plus k to maintain this index, that it is possible, it is possible that after adding plus a k to my indexes, it can go out of bound. It can be greater than, it can be greater than n. So we need to take modulus for that, we need to take a modulus for that. So ultimately, after after returning, before returning the answers, before returning this answers, I need to take a modulus of this. I need to take a modulus of this, right? I need to take a modulus of this with n, because index cannot be greater than this n, because we have started from 0, 0th index till 2, 0th index to 4. So that's that would definitely never gonna get greater than equals to 5. So that's, we need to take a modulus of that, right? So we will use the same recursion for occurrences in our implementation. You will better understand that. Let's see the implementation purpose, right? So basic relation is just this. If you find the relation, you solve this problem. If you don't find, it's hard to solve this, right? So this is just a math tricks. So let me remove this, because we don't need this. We don't need this, right? So basically, let's start from, right. So what we need to do, we need to call for fnk, right? We need to call for fnk. So we will return. So what we will do, we will return answer, solve, and k, right? Now we will pass this values. Now what we need to do, we need to find the indexes of its lower value, which is n minus 1 value. This recur what this values, right? This is the relation ultimately we need to find, right? So what we will do, we will, I need to find, I will find its previous values. I will find its previous values. That would be x. So I will find for x, and what it will be, it will be solve n minus 1 k. So what it will give, it will give me some indexes, and I need to update the current index. So that would be x plus k. That would be x plus k, because it will give me some indexes, and that's need to be updated for this x plus k, because this will give me minus k, because it is reduced the indices by minus k. So that needs to be compensated by adding plus k, and this is the, this will be the my the current index, right? This will be the my current index. So this needs to be returned. This needs to be returned, and that would be return y. That would be return y modulus n, because this would can be go to higher than value. So this need to be returned. So before that, now this n minus 1 k again goes and goes and goes on. When this will be stopped, right? This will be stopped at n is equals to 1, right? This will need to be start n is equals to 1. When we have left only one element, it definitely will be at return 0, at index 0. This is the base case. When n is equals to 1, it will be definitely at my index 0. This is representing index. This solve function is representing index. It is giving me index, and this is this is updating new index, updating new index according to the index which we have provided by this solve function, right? After that, we will just return our answer, which will be an index. But one thing is needs to be checking, that we have started from 0 index. If you see here, we have started from 0 index, but friends number started from 1 2 3 4 5. It means we I need to add plus 1 to this answer to get the original friend number, which is not started from 0, which is started from 1. And this answer will give me the index which is started from 0. So I need to add 1 here. So this is how we will just solve the problem. See, to think this thing, we needs to, we think of all these things, right? So this problem is the famous problem named as Josephus problem. If you see, you can search this as a problem as Josephus problem. This is the same problem. You just need to remember that how will this matrix implement for the circular part, right? This is how we solve the problems. Let's try to run this and see whether we have done it right or not. We have passed the sample case. Let's submit it. Yeah, we have passed the cases. So this is a recursive function. So if you take an auxiliary, so time and space complexity would be, so time complexity is O of n for sure, because you iterate in O of n minus 1 till O of 1. So O of n for sure. The space complexity is, so if you don't consider, if you consider auxiliary stack space, so this is O of n for sure. But if you don't consider this, this is O of 1, right? This is O of 1. So this is due to this recursion, this is O of n, otherwise this is O of 1. You can do this in iterative way also. So to reduce this auxiliary stack space to O of 1, right? Time complexity would be same. You can do this in iterative way also. So what will happen? We will start from, so basically doing from recursion to iterative. You just need to simulate this things to iterative way. So what we will do? We will just change this, right? So just remove this, and now, so what is happening at n is equals to 1, n is equals to 1, we are returning 0, right? It means that the position of n is equals to 1 would be definitely 0, right? And for each position, it is updating by x plus k. The new position is updating by x plus k. So we will use that. So see, answer would be 0 for n is equals to 1. So n is equals to 1 solved. Now we will iterate from n is equals to 2 till where? Till n. So this is bottom up approach. Now we will this is top down approach. We will have started n minus 1 till n is equals to 1. Now we have started from first part. So for n is equals to 1, the base case is the index is 0. Now we will start from 2, n is equals to 2 part. For that, what will happen? So it will be get updated again, the same thing. See, the same thing. So this answer is, we will use the same thing, right? We will use the same thing. So this solve n minus 1 is what? This is answer, right? This is answer. So we will use this answer as this. This y is updated value, which is x plus k. Now when we again comes to this answer needs to be updated as y, we are, because we are returning y modulus n, right? So this answer should be, must be y modulus n, right? This answer modulus n, because when we come next time it is returning y modulus n, so answer should be updated to y modulus n. This will be not modulus n, this will be modulus I, because the the nth element till is 2 now, right? Because we have updated, we have not updating for n, we are because n is updating again and again from here, right? N is updating. So this I is, this I is also updating till n element. So this must be y modulus I. So instead of this is same thing. You can write it for, to simplify, is answer plus k modulus I. This is the same thing, right? To simplify this process. And at last we will return 1 plus answer, which is our answer. Just run this. Yeah, we have passed the cases. Let's submit it. We have passed it, right? So basically it is now the space complexity is over 1, because we haven't used anything, and the time complexity will be same, O of n, right? So this is how we will solve this problem. So basically the question is hard till, because the question is not hard, it's just that you know it's math tricks. So math tricks, so you can solve this, otherwise it is hard, right? Hope you liked it. So thank you so much. Bye bye.